All right, here we go. So the other day we took our exam on law of sines, cosines, word problems, SOHCAHTOA. Today we expand on that a little bit. All right, so think back to geometry. How would you find the area of the following? Well, to find the area of the following, right, area of a triangle is base times height divided by 2. So this first one, 3 times 4 divided by 2, 6 units squared. All right, second one, a little bit more complicated. So those tick marks mean that if that's 12, that's also 12, making this side 24. And understanding that base times height divided by 2. Base is not necessarily the bottom. Base is where the right angle goes to. All right, so for this one, base is 24, our height of 5 divided by 2, 60 units squared. Now for this last one, what's the issue? We can't do base times height divided by 2. Why? We don't have a height line. Where is our right angle? All right, so since we don't have that, we have to mathematically figure out a new way to do this. All right, so issue. How are we going to solve this? All right, so A is 8.4. C is 20. This is 108 degrees. All right, so let's go through this. Let's go through this and find our information. So kind of practice things out. So we know we have law of sines. So if we wanted to solve this triangle out, since we have our complete ratio, 20 over sine of 108 equals 8.4 over sine of angle A. Sine of angle A equals 8.4 times sine of 108 divided by 20. We do the inverse of this number and we get our angle. Where'd my calculator go? All right, 8.4 sine 108 divided by 20. Inverse of that, and we get our angle to be 23.54 degrees. So angle A is 23.54 degrees. That would make angle B 180 minus 23.54 minus 108, 48.46 degrees. Right, so I got A and B. All right, what's the last thing I need here? I need side B. So side B, I go 20 over sine 108 equals, in this case, B over sine, B over sine 48.46. I'd cross multiply and solve. I get B to be 15.7. All right. So there's all our information. Now again, how do we find the area of this? Well, we need a new setup. We don't have a height line. Right? You can make a height line. I'm not promoting it. It's a little bit tricky, but you could if you wanted to. But we need a new area setup. So we have a formula. Area equals 1/2 AB sine C, 1/2 BC sine A, 1/2 AC sine B. The key thing is that to be able to use this formula, you have to have side angle side. If you have a picture where you have this side, and this angle, this side angle side setup, you can find the area of the triangle. All right, so if we look at this, area equals 1/2. Where's my side angle side setup? There. Two sides with the angle between. 8.4 times 15.7 times sine, zoom out, sine of 108. If we do that, our area is 8.4 times 15.7 times 0.5 times sine 108. Our area is 62.71 units squared. you know, yes, you're looking at that. I'm just telling you, but it does actually work. If we look up here, right, there's my side angle side setup. Area equals 1/2 3 4 sine 90. All right, so 1/2 times 3 times 4 is 6 sine 90. Well, if we go back to our unit circle, 90 degrees is up here. Sine of 90 is our y value. Know what? It's 1. So this is 6 times 1, which is 6. It works exactly like it did before. All right, if we look at this, right, again, area equals 1/2 5/12 sine 90 again. All right, so we'd have in this situation 30 sine 90 equals 30 times 1 to get 30 degrees, 30 units squared. All right, well, and since these are congruent, they're both 30. All right, so our formula does work. So this is our formula to find the area of a triangle without a right angle. All right, now, before we can do this, but we can now, 1/2 15 13 sine of 54. All right, if we type that in, 15 times 13 times 0.5 times sine 54, 78.88 units squared. Done. We're able to do it. New formula. All right, so there's our new formula. All right, so let's look at this example. Find the area of this triangle. All right, so if I look at my picture, A, B, C, A is 18 degrees, B is 70 degrees, A is 14, B is 32. So based on what I have right now, I do not have the side angle side. Well, guess what? I can figure out this angle. 180 minus 70 minus 18 is 92 degrees. There's my side angle side setup. Area equals 1/2 14 times 32 times sine of 92, which is, in this case, 227.06 units squared. Done. All right, what about this example? A, B, C. A is 6, B is 4, C is 5. So I obviously have the three sides. I don't have an angle. What can I do? Law of cosines. All right, well, I'm going to do law of cosines for angle A. 6 squared equals 5 squared plus 4 squared minus 2, 5, 4 cos of A. So I got 36, 25 plus 16 minus 40 cos of A. All right, so I subtract 16. I got -5 equals -40 cos A. I got 0.125 cos A inverse, and my angle is 82.82 degrees, which now I'm good to go. 82.82 degrees, there's my side angle side. Area equals 1/2 4 5 sine of 82.82. Type into my calculator, the area of this triangle is 9.92 units squared. Alright, but we got another formula. Right? Different scenario, different way to attack the problem. So what we did up top for this problem too works out perfectly. But there is another formula. It is called the hero's formula. So the hero's formula is used when we have side, side, side. So the formula is area equals S minus A, S minus B, S minus C, all under a big rad. And S is half our perimeter. So if I take this new formula and apply it to what we had above. All right, so S equals half the perimeter, which in this case is 15. So S is 7.5. So our area formula is 7.5. Now it's 7.5 minus 6, so 1.5. 7.5 minus 5, so it's 2.5. And 7.5 minus 4, which is, come on, right, 3.5. So if we type that whole thing into our calculator, the square root of 7.5 times 1.5 times 2.5 times 3.5, what do I get? The exact same answer. So it doesn't matter which formula you use, you're going to get the exact same answer either way. Alright, time to practice. Okay, what do we got here? A, B, C. A is 3, B is 2, A is 24 degrees. Alright, I need more info. I don't have enough information here. Alright, so what can I do? I got my ratio, I can do law of sines. 3 over sine 24 equals 2 over sine B. So if I cross multiply, go through the whole process, 2 sine 24 over 3. Inverse of this whole thing, I get B to be 15.73 degrees. So if that's B, angle C, 180 minus 24 minus 15.7, 140.27 degrees. And that is key. That is the angle that goes here, and that is the angle that gives us our side angle side setup. So what is our area? 1/2, 2, 3, sine of 140.27. Area equals 1.92 units squared. Super tiny triangle, but whatever. That's what we got. Okay. C, B, H. H is 3. C is 24. H is 24. Alright, what's the issue we have here? Alright, what I notice right away is, since these are congruent, we have an isosceles triangle. And if the legs are if the base angles are congruent, so are the legs. Alright, so if I know that the two bottom angles are 24, 180 minus 24 minus 24, 132 degrees. Area equals 1/2, 3, 3, sine 132. Area equals 3.3 units squared. Alright, so I got 3 sides. DKP 6, 14, 24. So since I have 3 sides, I can use that hero's formula. S equals half the perimeter, which situation S equals half of 44, which is 22. Jump into my formula. 22 times 22 minus 6, 22 minus 14, 22 minus 24. Alright, so if we work this whole thing out, what we learn is that this is a negative number, which tells us error on the calculator. Alright, why is it telling us error? The issue is this. This is not a triangle. If we have a setup where we have a length of 24, we have a length of 6, we have a length of 14, it is physically impossible for this to connect to make a triangle. 6 plus 14 is 20, it's not greater than 24. So we didn't pick up on it right away, but the calculator could tell no way is this going to happen, because to be a triangle, the two smaller sides must add to be larger than the largest side. Now with this last example, let's see if this one actually works. DGH 794, S equals half the perimeter, so we got half of 20, which is 10. Area equals 10, 10 minus 9, 10 minus 7, 10 minus 4. Area equals 13.4 units squared. Done. All right, so